Hello, I'm Clay Hedrick. Welcome to Baker Products. What I want to do today is show you around our 3665D sawmill. As you can see, this is a very heavy frame mill. We use I-beam on the side of this mill instead of tubing. Half-inch bunks in the machine. They're placed close together. You look at some of the other mills that might have 7, 8, 9 bunks in them. This machine's got double that at least on a standard 20-inch frame. 65 horsepower Cummins engine is standard. There's a turbo available as well on the machine to up the horsepower. Everything on the machine is hydraulic. You got hydraulic tow rollers up and down. Your fence arms are hydraulic. Your clamp, your log turner, your debarker, the head back and forth and up and down on the machine are all hydraulic. No 12 volts on this machine at all. Legs. We don't use jacks for our legs at all. This is heavy duty 4x4 tubing legs. That way when you're moving this mill head back and forth, you don't get any sway like you do with turn jacks like you do on a normal trailer. So that eliminates that. All these are able to adjust freely. Set them wherever you want. Comes with a jack stand to do your final adjustments on them as well. Heavy duty log turner in the machine. Again, all hydraulic, runs forward and reverse. There's 3 pieces of half-inch steel plate in this, all laser cut, precision made like the rest of the mill. For your log turning. Clamps, both up and down and back and forth hydraulically on it. As you can see, these are all solid steel, clamps and fence arms, as well as the bar that this clamp runs back and forth on is solid steel. Another tow roller in the machine. This machine has a 22-gallon fuel tank in it. It's mounted right into the frame of the machine. A lot of mills come with just a small 5 or 6 gallon tank on them. You have to refuel during the day. This allows you to saw all day and never worry about refueling the mill. Standard tongue jack. On the front, it's 2 5/16 ball hookup, tandem axle trailer with electric brakes. On this side, you'll see one of the log loading arms that we have down right here. Same thing again, heavy duty half-inch plate steel on these. This log loader arm is adjustable up and down this piece of tubing. So depending on the length of your logs, you can actually adjust your log loading arm to assist your log loading. This is a dual cylinder, dual hydraulic cylinder log loading arm. The other arm during towing is located at the back of the mill here, and there's a cutout in the fender right here where this particular loading arm goes. You don't have to remove the fenders when you set this mill up at all. They're solid steel welded right onto the machine, so you don't have to mess with that. This has an outrigger arm on it as well. This outrigger arm comes down. It stabilizes this machine from this side. When you got big logs, big heavy logs, this will stabilize the machine, that force you get when you pick up the mill to this side. So it eliminates that. You'll also see the hydraulic debarker on this side. It's got an activation switch at the operator station. It's a dual chainsaw chain debarker is what it is. We wanted to do something that was simple, easy to get. Don't have to worry about carbide tip blades or anything like that. It's just a standard chainsaw chain, 2 rows of it on here, and does a great job, runs right in front of your blade to clean off those dirty logs. Another thing on our machine, the way it's designed, when you make your first cut and you clean off that top of the log, first time you turn it into your fences, the blade's coming into the clean side of the wood. So that eliminates sawing 3 sides of your log, possibly dirty logs, before you get into clean wood. So that'll help your blade life for this machine as well. This machine happens to have an optional laser light on it. It's available on all our mills if you want it. On the back side right here is our tensioning system. It's hydraulic as well. Basically, this is a hydraulic pump, hand pump. depressurize and set your tension. And we've got it right on here marked down the PSI it needs to be set at for your blades. Once you develop that tension on your gauge, you've got the proper tension on your blade. This system allows for some variances in blade length or as your blade stretches. All that's built into this system to allow for that. So you don't have to have the perfect blade length to get the right tension on your blade, or even as your blade stretches, or you use it multiple times, sharpen it and it stretches over time, then this will adapt to that length change and set your tension properly. You have a tank up here for your drip to lubricate your blade. You can choose whatever you would like to do to drip on your blade. Some people like diesel fuel or kerosene or transmission fluid, something like that. Most of our customers, and what we typically use, is water mixed with Dawn or Tide or some kind of dishwashing liquid, something like that. It lubricates, but there's no fire hazard with it. There's no environmental impact with it. If you're out on another person's property, they may not want that diesel fuel or something mixed in that sawdust on their property. So it's always a good alternative. In the winter time, windshield washer fluid is a great idea. Won't freeze, does the same thing. So you can see from this side, good view of the tandem axle. You can see our dial up there, marked off. We've done this nice big visible dial so that when the head is away from you, you can see it. There are other gauges and ways to put scales on there, but they don't give you a good view. You have to be pretty close to them to read them. So this gives you an easy way to see your log scale, telling you where you're at off the bumps. This machine has optional setworks package on it. You have both basically 8 board sets can be pre-programmed in the machine at any given time. You have 8 core sets that can be in it at any given time as well. So you can set that for, say, 1 1/8 lumber that you want to saw. When you hit your set button here, it will go to that 1 1/8. When you get to the end of your log and you made that cut, you hit the offset button, it raises up, then your board drag backs will bring your board back to you right here to deal with it. You can then hit set again, and it'll make that 1 1/8 set again. It always knows where it's at. Even if you hit this offset at the end, manually raise the head up higher for whatever reason, then bring it back and hit set. It will still set the right set to make your cut. It remembers where it's at. 4 settings allow you to make a couple cuts on the log, get to that 3rd face, and tell the machine basically you want to make a 7x9 tie or 4x6 cant, whatever it is you want to make. And it will take the shim cut out of the slab, your outside cut, and then let you make the maximum number of 1 1/8 boards, if that's what you're making, down to that square size. When you get down to that square size, you won't have to shim cut it to size it properly. It's already taken that into account at the top side. Lots of sawyers do that manually in their head. They've learned the math, memorized the math, and can do that. So it's no problem. If you want to manually saw that way, you can do it as well. Flow control valves located right here, convenient so that you can speed the mill up, slow it down depending on your species or log diameter or what you're doing at the time. All your controls are located here for the mill. Log handling, head up and down, everything's located right here. They're broken up into the 2 different types of things that you'll be doing. One, the log handling, and the other one, the sawing, basically. Your head up and down, forward and reverse, your log turner, all that's right here. Throttle controls right here. It's set. Basically, when you're sawing, you want that throttle wide open to saw maximum RPM the way we've got it set. You have an all-stop to shut everything down as well, shut the engine off. These controls, as an option, some customers like to have these controls off the mill, so we can build you a stand if you want, so they can be set to the side if you prefer to do that. All right, I'd like to show you the inside of the machine. One of the first things you're going to notice is this big wheel. It's a 28-inch diameter solid steel wheel. We make these on site, and they're all machined. Every face on the wheel is machined. We machine the front, the back, the inner circles, of course where the bearing mounts, that's all done. And then most importantly, we machine the outside of this wheel and put a crown on it so that the blade tracks properly on it. There's other designs out there. This is an industrial design, something that you would see in $1 million 12-inch band mills, for instance, is this type of wheel used. The next thing you'll notice is we don't use a pillow block bearing system with a cantilevered shaft with the wheel hanging out on the end of the shaft. These wheels are heavy. There's a lot of tension on these blades, which pulls on the wheel. And what happens is you got two pillow block bearings in the back. You got this wheel hanging out on the end. The weight of the wheel as well as the pressure of the tensioning, and that puts a lot of pressure back here on these bearings. And what we do is just like your car hub or truck pickup, whatever you've got, the weight of the wheel and the tension is centered between two bearings in this sealed bearing system. This hub design is exactly what you would find in a car or pickup today. The same thing. And you know how many thousands and thousands of miles you get out of those on a vehicle. They hardly ever fail. It's a sealed bearing system. It's a great design. You don't have to worry about greasing them, over greasing them, pushing seals out of them. So that eliminates part of that maintenance issue. Both wheels on both sides, both this pull wheel and the idler wheel, you have adjustments for your wheel, both horizontally and vertically, so that the tracking can be set perfectly for your blade. So each wheel can be independently adjusted to get it in the correct plane to run properly. Something else you'll notice in here is a centrifugal clutch. This clutch basically engages at 1,000 RPM, so the blade's not turning. You start your motor, it can idle. It'll sit here and the blade will not move. When you throttle it up, start to saw, that's when it will engage and turn your wheels into band blade. Have a movable guide arm. The fixed side runs along your fence basically, the log on that side, and then this side is movable. Of course, that controls back with the rest of the controls where the operator's at, and he can move that on the fly as he saws if he follows the contour of the log if he wants. The guide system that we use standard is a flat guide system. This has been a great system for us. We've used for almost 30 years on our machines. We don't change the plane of the blade. When it comes off the bottom of the wheel, it stays exactly where it's at. We have the guide system set up where you're holding the blade top and bottom. So if that blade tries to move up or down, it's held both directions. We're allowing it to run straight through there. What we found years ago by doing this is if we're not deflecting that blade another direction, it's already coming around these wheels and being bent. We're not bending that blade again, creating any excess heat or tension or anything in the blade that can cause a problem. And this is our preferred method. If you do prefer roller guides, if you've run them in the past, you're used to them, you like them, we can offer those on the machine as an option. You hear a lot about heavy duty when people are talking about their mills. This mill, as far as I'm aware, is the only one that's built like this with an I-beam frame. As you can see, this is a full 12-inch I-beam, both sides. 4-post head design, of course, on this. The bunks, I mentioned before, we put them closer together. They're solid steel, laser cut. Where the log turner goes, it's double plated to beef that up as well on the mill. We weighed this mill just earlier, and this is a 10,600 pound mill. Everything about it is beefier, heavier, and part of that's come from our experience. We just don't build machinery. We log ourselves. Our full logging crews do mechanized logging. We've got a full scrag mill, and we have one of our electric stationary dominator mills that runs every day, 2 shifts a day, with the same I-beam design in it. But it comes from our experience being in the wood business, knowing what these machines need, the abuse that they can take. If you're going to run one of these and make a living with it, and it's going to be out there every day, 8, 10, 12 hours a day, It's got to be built right. We've not just thrown steel at it. We've built this machine the correct way to take that and work day in and day out, day after day for you with as little problems as possible.